two beautiful little Chinese girls.
This is the doctor who changed the future of the human race and let the world know on YouTube. He Jiankuai stunned the scientific community with the claim he pushed the boundary no one else had.
A line has been crossed that should not have been crossed.
It's very disturbing. It's inappropriate.
Oh, this is huge.
These genetic testing companies have become quite popular both in the US and in China, but for very, very different reasons. In the US, most people take these tests because they want to know a little bit about where they come from. They want to know their heritage, their lineage, and whatnot. Here in China, though, people want to know what their DNA says about them.
Are designer babies with enhanced intelligence or strength just around the corner? The technology that makes this important conversation possible is called CRISPR, a revolutionary gene editing tool that allows
15 powerful examples of the potential of CRISPR-Cas9 gene editing method. CRISPR, or Cas9, is a gene editing method that allows scientists to make precise changes to specific parts of a genome. This technology has the potential to revolutionize medicine and has been widely studied by scientists in recent years. It is important to note that while CRISPR-Cas9 has the potential to enable these and other scientific breakthroughs, it is still a relatively new technology that is being extensively studied and tested. Further research and development will be necessary to fully understand and harness its potential. Here are 15 potential scientific breakthroughs that could be achieved if doctors are able to fully harness the potential of CRISPR or Cas9. If we can, we're going to update this list in the future. Number 1. Creating new treatments for diseases and genetic disorders by editing genes that cause these conditions. For example, CRISPR-Cas9 could be used to edit the genes that cause cystic fibrosis, a genetic disorder that affects the lungs and other organs. By making precise changes to the genes that cause this condition, scientists may be able to develop new treatments that can alleviate the symptoms of cystic fibrosis or even cure the disorder. For example, CRISPR-Cas9 could be used to edit the genes that cause sickle cell anemia, a genetic disorder that affects the blood. By making precise changes to the genes that causes this condition, scientists may be able to develop new treatments that can alleviate the symptoms of sickle cell anemia or even cure the disorder. Number 2. Developing personalized medicine by using CRISPR-Cas9 to edit a person's own cells and tissues for therapeutic purposes. This could involve taking cells from a patient, editing their genes using CRISPR-Cas9, and then transplanting the edited cells back into the patient to treat a disease or condition. For example, CRISPR-Cas9 could be used to edit the genes of immune cells to make them more effective at fighting cancer or other diseases. Developing personalized medicine could be used also to edit the genes of stem cells to make them more effective at repairing damaged tissues or organs. Number 3. Developing new ways to detect and diagnose diseases by editing genes that produce diagnostic markers. For example, CRISPR-Cas9 could be used to edit the genes of bacteria or viruses that cause infections, making them produce a unique protein or other marker that can be detected by a diagnostic test. This could provide a more sensitive and specific way to diagnose diseases caused by these organisms. For example, CRISPR-Cas9 could be used to edit the genes of pathogens that cause infections, making them produce a unique protein or other marker that can be detected by a diagnostic test. This could provide a more sensitive and specific way to diagnose diseases caused by these pathogens. Also, CRISPR-Cas9 could be used to edit the genes of bacteria that cause pneumonia, making them produce a marker that can be detected by a diagnostic test. This could provide a more accurate and sensitive way to diagnose pneumonia and other respiratory infections. Number 4. Creating new animal models for studying diseases by editing the genes of animals to mimic human conditions. This could involve using CRISPR-Cas9 to edit the genes of mice or other animals to create models of human diseases, such as cancer or Alzheimer's disease. These models could then be used to study the biology of the disease and to test new treatments. This could also involve using CRISPR-Cas9 to create models of human diseases, such as diabetes or obesity. These models could then be used to study the biology of the disease and to test new treatments. For example, CRISPR-Cas9 could be used to edit the genes of mice to create a model of obesity, allowing scientists to study the effects of obesity on the body and to test new weight loss treatments. Number 5. Engineering new crops with improved traits. such as increased yield or resistance to pests and diseases. For example, CRISPR-Cas9 could be used to edit the genes of plants to make them more resistant to pests or diseases, or to increase their yield or nutritional content. This could have major implications for agriculture and food production, potentially leading to more sustainable and efficient farming practices. Also, CRISPR-Cas9 could be used to edit the genes of corn or other crops to make them more resistant to pests or diseases, or to increase their yield and nutritional content. Finally, CRISPR-Cas9 could be used to edit the genes of corn, reducing the need for chemical pesticides, and improving the sustainability of corn production. Number 6. Creating new biofuels by editing the genes of microorganisms that produce these fuels. CRISPR-Cas9 could be used to edit the genes of yeast or other microorganisms that are capable of producing biofuels such as ethanol or butanol. This could potentially lead to the development of more efficient and sustainable methods for producing biofuels, which could be used as a renewable source of energy. This can be a game changer in the future. CRISPR-Cas9 could be used to edit the genes of algae or other microorganisms that are capable of producing biofuels such as biodiesel or hydrogen. This could potentially lead to the development of more efficient and sustainable methods for producing biofuels, which could be used as a renewable source of energy. Also, CRISPR-Cas9 could be used to edit the genes of algae to make it more efficient at producing hydrogen, potentially leading to the development of a new and sustainable source of clean energy. Number 7. Developing new vaccines by using CRISPR-Cas9 to edit the genes of viruses and bacteria that cause diseases. This could involve using CRISPR-Cas9 to make specific changes to the genes of these organisms, making them less virulent and more immunogenic. This could potentially lead to the development of new and more effective vaccines against a variety of infectious diseases. This is revolutionary, as it involves using CRISPR-Cas9 to make specific changes to the genes of these organisms, making them less virulent or more immunogenic. This could potentially lead to the development of new and more effective vaccines against a variety of infectious diseases. Also, CRISPR-Cas9 could be used to edit the genes of the influenza virus, making it less able to cause severe illness and more easily recognized by the immune system. This could potentially lead to the development of a new and more effective influenza vaccine. Number 8. Developing new methods for gene therapy by using CRISPR-Cas9 to correct genetic defects in cells and tissues. Gene therapy involves using genetic material to treat or prevent diseases. CRISPR-Cas9 could potentially be used to deliver the genetic material to specific cells or tissues, where it could be used to correct genetic defects or introduce new therapeutic genes. This could lead to the development of new treatments for genetic disorders and other diseases. This could lead to the development of new treatments for genetic disorders and other diseases. For example, CRISPR-Cas9 could be used to edit the genes of cells in the liver to correct a genetic defect that causes a deficiency of a vital enzyme. Number 9. Developing new treatments for cancer by editing the genes of cancer cells to make them more vulnerable to drugs or the immune system. CRISPR-Cas9 could potentially be used to edit the genes of cancer cells, making them more susceptible to the effects of drugs or the immune system. This could lead to the development of new and more effective treatments for cancer, potentially improving the survival rates and quality of life of cancer patients. CRISPR-Cas9 could be also used to edit the genes of cancer cells to make them more susceptible to the effects of chemotherapy, potentially making the treatment more effective and less toxic to healthy cells. Number 10. Developing new drugs by CRISPR-Cas9 to edit the genes of cells that produce drugs. CRISPR-Cas9 could potentially be used to edit the genes of cells that produce drugs, such as antibodies or other proteins, making them more efficient at producing the desired molecule. This may sound crazy, but it is completely possible. It can help the development of new and more effective drugs, potentially improving the treatment of a variety of diseases. For example, CRISPR-Cas9 could be used to edit the genes of cells that produce antibodies, making them more efficient at producing a specific antibody that is effective against a certain type of cancer, potentially leading to the development of a new and more effective cancer drug. Number 11. Creating new animal models for studying development and aging by editing the genes of animals to study the effects of these processes. For example, CRISPR-Cas9 could be used to edit the genes of mice or other animals to study the effects of aging on the brain or other organs. This could provide new insights into the biology of aging and potentially lead to the development of new treatments for age-related diseases. Also, CRISPR-Cas9 could be used to edit the genes of mice to study the effects of aging on the heart, allowing scientists to better understand the underlying causes of age-related heart disease and to test new treatments for this condition. Number 12. Developing new methods for regenerative medicine by using CRISPR-Cas9 to stimulate the regeneration of tissues and organs. Regenerative medicine involves using biological or medical techniques to repair or replace damaged or diseased cells, tissues, or organs. CRISPR-Cas9 could potentially be used to edit the genes of cells involved in tissue regeneration, making them more effective at repairing or replacing damaged tissues. This could lead to the development of new treatments for conditions such as heart disease or spinal cord injuries. For example, CRISPR-Cas9 could be used to edit the genes of stem cells to make them more effective at repairing damaged heart tissue, potentially leading to the development of a new treatment for heart disease. Number 13. Developing new treatments for neurodegenerative diseases by editing the genes of nerve cells to protect them from damage. Neurodegenerative diseases are conditions that involve the loss of nerve cells in the brain or other parts of the nervous system. CRISPR-Cas9 could potentially be used to edit the genes of nerve cells, making them more resistant to damage or death. This could lead to the development of new treatments for conditions such as Alzheimer's disease or Parkinson's disease. For example, CRISPR-Cas9 could be used to edit the genes of nerve cells to make them more resistant to the toxic effects of amyloid beta, a protein that is believed to play a role in the development of Alzheimer's disease, leading to the development of a new treatment for Alzheimer. Number 14. Developing new methods for gene editing in plants and animals by improving the efficiency and precision. CRISPR-Cas9 is a powerful tool for gene editing, but it is not perfect. Further research and development could potentially improve the efficiency and precision of CRISPR-Cas9, making it more effective and versatile for a wide range of applications in plants and animals. For example, scientists could develop new CRISPR-Cas9 systems that are more specific and less likely to cause off-target effects, making it possible to edit the genes of plants and animals with greater precision and accuracy. This could have a major impact on agriculture, animal husbandry, and other fields where gene editing is used. Number 15. Developing new methods for gene editing in human cells by improving the safety and ethical considerations of CRISPR-Cas9. While CRISPR-Cas9 has great potential for treating diseases and improving human health, there are also ethical concerns about using this technology to edit the genes of human cells. Further research and development could potentially address these concerns, leading to the development of a safer and more ethical methods for gene editing in human cells. For example, scientists could develop new CRISPR-Cas9 systems that are more precise and less likely to cause off-target effects, reducing the risk of unintended consequences when editing the genes of human cells. This could help to ensure that gene editing is used in a responsible and ethical manner, while still allowing for the potential benefits of this technology to be realized. That is all for today. We hope you enjoyed our video and learned a thing or two about CRISPR-Cas9 technology. It is clear that biotechnology is currently reaching a peak of innovation that can change our world. If you want to know more about value creation in the world, just click on the link in the video description. Subscribe to our newsletter to download your copy once we launch our book, The Ways of Capitalism. Please share this video if you like the content and subscribe.